All right, welcome grade 8. In this particular video, we're going to be stepping through the exercise 7.2 practice questions. Again, this is just for those of you who might need a little bit extra help or explanation as you're going through the questions. I would like you to try the questions first before you check out some of these solutions within this video. So for the first set of values, we're given certain triangles and we're asked to solve for angle x. So in 1a, we're given the triangle that looks a little bit like this. We're given that this is 65 degrees, this is 38 degrees, and then this is our x value here. This is one of the classic examples of just having a triangle and trying to figure out what's remaining of the 180 degrees that would be in a full triangle. So if this is 65 and this is 38, we bring that together and we get 103, which means that x is just whatever's remaining from the 180 degrees. We take 180 minus that 103, and we get a total of 77 degrees. So this value here is 77 degrees. You can always check your answer by saying, okay, this plus this plus this, does that equal 180? If it does, you're good. If it doesn't, double check your answer. B. We're given a similar triangle in B, and it's the same sort of way of solving it. We are given values of 30, 32 degrees, of 35 degrees, and of x. Again, we just need to figure out what's remaining of the 180. So 32 plus 35 means we already have 67 degrees. We just take 180, subtract that 67 degrees, and we figure out that x, the remaining amount, is 113 degrees for our answer. And again, 32 plus 35 plus 113 equals 180. In example C, we're given a triangle here. This one's a special type of triangle. And we know that it's a special type of triangle because of the two lines that are here. These two lines mean that they are the same length, which means that this is a triangle called an isosceles triangle. And an isosceles triangle, where the two lines kind of come down and meet a separate line, not where they meet each other, those angles are always going to be the same. So if this is 63, this is also 63, and we can use that to solve our remaining angle. So 63 and 63 is 126 degrees in total. What do we need left to get to our 180? Take 180 minus 126, and you'll see that we have 54 degrees left for that angle x. All right, let's move on to D. We have another triangle here, and this is another isosceles triangle. This one's just kind of on its side, though, and so we know that by the two lines here. So we see this is 54 degrees, and this is x. Now, we don't know this one here. We know, though, that these two are the same. So let's take 180 degrees, subtract the 54 degrees, and see what we have to work with. When we do that, we get 126 degrees that are left, 126 degrees that have to be split equally here. So when I divide this in half, divide that by 2, I get 63 degrees on either side, which is my value then for x. It would also be the same here. This would also be 63 degrees. What's interesting about this particular question is it's exactly the same as C, just on its side. Now we move on to 2, where we're dealing with exterior angles as opposed to interior angles. So I have a triangle that's here, but I have a line that extends, and I'm asked to solve this missing angle here. I know that this is 52 degrees, this is 80 degrees, and if you remember our rules about exterior angles, the rule is that the exterior angle is the sum of the two opposite interior angles. So these two added together is going to be the same as this one, which is simple enough. I add those, 80 and 52, means that this angle is 132 degrees for 2A. 2B. I'm given a similar type question. It's just from a different kind of point of view. So there is my angles. This is 22 degrees. This is 114 degrees. And then this is my angle y. Remember that this exterior angle is going to be the sum of, or adding, these two opposite interior angles. Add these two together. 114 plus 22 gives me 136 degrees, which is the answer for that exterior angle. C. C, we're going to use some of the information that we have, but we're going to have to go a little bit further with it. So we have a line that comes down here, and then we have a triangle that's inside here. This is 50 degrees, this is 80 degrees, and we're asked to figure out this angle Y right here. So a couple of bits of information here. We're now not trying to find the exterior angle, we're trying to find the interior angle, but we use the exterior. Remember that in this case here, if this is the exterior angle, then this plus this have to equal this value. So in other words, what can I add to 50 to get to 80? It's just another way of thinking as we're going through this question. And we need 30 more degrees in order to get to 80 degrees. And so that is our Y value for that question. D. In D, we have, again, a similar situation to C, almost the exact same, actually. And then we come up, and it comes across. The only difference here is that it seems like we're given less information, but we're not really, because there's a little square here that means that this corner is a right angle, and any right angles are 90 degrees. Automatically, all of them are the same. So it's the same sort of question. I have an exterior angle. What can I add to 90 for this Y in order to get me to that 150? And I need 60 degrees more, so that means that my Y value must be 60 degrees for that question. Question 3 has us doing two things. It has us not just finding angle X or finding angle Y, it actually has us finding both angle X and angle Y in a particular question. So 3A, we have a setup where we have a straight line and we have a bit of a triangle on that line. We have 136 degrees here. We have X, we have Y, and we have 112 degrees here. Now, in order to solve this particular question, there are multiple ways to go about doing it. One of the ways to start, I would just start off with this X. I would say if this is 136, then to get from here to here is 180. What do I need left for that X to be? Well, 180 minus 36 is going to give us 44 degrees for our X value. Now, in order to figure out our Y value here, we're going to start by figuring out this value, this missing one, first. What's left here from the 180? Well, if this is 112, 180 minus 112 is going to give us 68 degrees. And we know that Y must be whatever's remaining, 180 degrees. The triangle is 180 degrees. This is 44. This is 68. Okay, or 112 degrees total. Y is whatever's remaining. And if I take 180 and I minus 112 from it, I figure out that Y is 68 degrees, which actually makes this an isosceles triangle. It would mean that these two lines are the same length, but that's just a little side note from here, and that's not part of the question. The question asks X is 44 and Y is 68 from this particular example. Let's move on to B from this question. So B gives us a similar type triangle. We have a line going straight across, or a line going up, a line going across, and then a line coming up to meet them. We see that this is our Y here, this is our X, this is 60 degrees, and this is 150 degrees. Okay, using that information, this would make 180, so this missing one is 30 degrees. This would make 180, so X is 180 minus 60, or 120 degrees. 120 plus 130 is 150, which means that this triangle, to get to 180, sorry, this is 150 still, this has to be the 30 degrees remaining in order to solve for what's left within that triangle. C. So in this case, our X is 120 degrees, our Y is 30 degrees. C. We're given a This time we're told that it's an isosceles triangle. By the lines that are put here on the side. This is 38 degrees. We're asked to figure out this y, and we're asked to figure out this x. Well, the x is nice and easy because it's an isosceles triangle. Because it's an isosceles triangle, if this is 38, this has to be 38 degrees. Now, this is an exterior angle. So as an exterior angle, it is going to be the sum of the two interior angles. 38 degrees plus 38 degrees is going to give us 76 degrees for our exterior angle for y. So a little bit easier even than A and B were, if you go about solving it the right way. And there are different ways to solve it. We could have also solved for this angle and then used the 180 trick in order to solve the rest. There's a couple of ways that we could have gone about solving that particular question. D, our final question here. We have a couple of bits of information. One, we know that we have an isosceles triangle, and we know that we have a right angle triangle. We're asked to figure out x and y, and that's all the information. We don't actually have any specific numbers for angles. But using that information, we know that this has to be 90 degrees. These have to be the same. So a triangle is 180 in total. I've already used 90 here. I have 90 left. I have to split that evenly, which means that this has to be 45 degrees, and this has to be 45 degrees. I could solve y now a couple of different ways. The one I'm going to choose to use is that this is 180. If this is 45, then what's left, 180 minus 45, is going to be 135 degrees for my value for y. I now have figured out that my x value is 45 degrees and my y value is 135 degrees. Hopefully that helped step you through some of the ways. There are many different ways to actually solve some of these answers. The ones that I showed you is just one way that you could solve these. But if you are stuck on a particular question, hopefully this helped you get you through these 7.2 practice questions.